So this is going to be the last main topic from section 3.1, and this is on the difference quotient. When we talk about lines, we're often interested in the slope of the line as a way of understanding how the line itself is changing. If we're working with something like f of x equals x squared, we might ask ourselves, what is the slope? And if it even makes sense to talk about the slope. If this was a normal class, this would be a great time to pair you up with partners and just have you think about what the slope would mean in this case. So maybe just think about it on your own for the time being. But we can give an estimate of what the slope is by using the difference quotient. If we're looking at f of x equals x squared, then we have 1, 2, 1. Let's put a dot there for 1. And up here at 2. Over here at 4. Then this branch, when we're on this narrow region of this parabola, it actually looks fairly straight. So the difference quotient gives us an approximate for what this slope should be. And let's actually define what the difference quotient is. So the difference quotient is f of b minus f of a over b minus a. So we can see that it's looking at, it almost looks like our slope formula, where we have, this would be our rise, and this would be our run. So for our example, b equals 2, a equals 1. We have f of 2 minus f of 1 over 2 minus 1, and that'll return 4 minus 1 over 2 minus 1, which is 3. So the slope is about 3. So that's how we interpret the difference quotient. And it gives us a way to say that between 1 and 2, we say the slope is about 3. In calculus, we take the idea of difference quotient and we push even further to talk about slope at a point, where in calculus we would look as the interval between, instead of it being from 1 to 2, we might look at it on a very small interval, like 1 to 1.1 or 1 to 1.001. It gets very close, and that gives us an idea of what the slope is at 1. In this class, we're just interested in finding approximates for the difference quotient. So finding how it changes, finding what the difference quotient is for two separate numbers as a way to estimate what the slope is. And with a quadratic, we saw it was pretty easy. We can find the difference quotient for f of x equals 1 over x at x equals 3 and x equals 5. And we just do the same thing. We look at f of 5 minus f of 3 over 5 minus 3. That's the same as 1 over 5 minus 1 over 3 over 2. This is where we have to make a common denominator. You can actually pull that divided by 2 out in front as a multiply by 1/2. We make a common denominator, get 3/15 minus 5/15. And that gives us negative 2 over 2 times 1 over 15, or just negative 1 over 15. We can draw a graph to actually see that looks reasonable. It's 1, 2, 5, there's 3. Our graph looks something like this. Where we have that point, and that's 1/5, and that's 1/3. So what we just said is that this slope, the slope connecting those 2 points, is approximately negative 1 over 15, which is good because we have a dotted red line with a negative slope, and our difference quotient said we would have a negative slope. So that's about it for the difference quotient. Hope you enjoyed. We'll be moving on to 3.2 soon.